FreeCAD has evolved rapidly recently. To make use of the new features, I'm doing a tutorial here to show you how to create this threaded bolt in just a few steps, for example, for 3D printing. Today, we want to design a simple bolt with a 1/4 inch internal thread and a square head. With the right approach, this is done in a few simple steps. To do this, we first create a new file. We select the correct workbench, in this case, part design. Then, we create a new sketch. For this, you may first need to select the body in the tree view on the left. Now, we select the plane we want to draw on. The XY plane makes sense here. It is important, especially for later, more complex drawings, to always construct around the origin as a central axis of symmetry. First, we want to create the square head for the bolt with a wrench size of 19 mm. We draw a rectangle around the origin in the center. We see 4 degrees of freedom in the sketch description, so we need to dimension the rectangle. To do this, we can click the lines themselves or the start and end points. For the position of an element, it is best to select the start or end point. The software will then automatically prompt for a dimension relative to the corresponding axis. The edge length is 19 mm, centered around the origin. Once the line is fully dimensioned, it turns green and can no longer be moved. You can always use this test if you are unsure whether an element is fully dimensioned, which happens quite often at the beginning. We do the same for the heath, and the entire rectangle turns green. The sketch description now says fully constrained. However, we still need a cylinder for the threaded bolt. So we draw a circle and set the origin as the center point. It is important to hit exactly the origin. That way, we won't need to dimension the center point later. Now, we can either dimension the 60 mm diameter directly or do it later with the dimensioning tool, or change it if needed. The entire sketch should now be green and fully constrained. If not, you might not have placed the circle center exactly on the coordinate origin and will need to add dimensions manually. Then, the sketch can be closed. All necessary elements are present in our master sketch, the square profile and the bolt shaft. Still in the part design workbench, we can now create a 3D body from this 2D sketch. For our sketch, the pet feature is the one we want. Depending on the part, there are many other ways to further process a sketch. If the sketch isn't selected automatically, we need to select it. The best way to do this is in the tree view on the left. After that, we select the faces in our master sketch that we want to extrude. First, the cylindrical shaft with a 16 mm diameter. The face changes color and we can select the pet option in the task panel. Here are several ways to enter the direction and length. A very practical new feature is the ability to change the values directly in the model using the displayed arrows. This gives you an immediate idea of what the part will look like later. We simply want to extrude 30 mm in the positive Z direction, which means upwards. So, we set the value to 30 mm using the arrow in the model or in the input field. The direction should be correct by default. We click OK and the shaft is finished. Now it's time for the square head. We select the sketch again in the tree view. Sometimes there is a bug here and not all selectable faces are displayed. If that happens, simply select the pet function once, cancel it and the face will be visible. This time, we only select the square and extrude it 10 mm in the same direction as the shaft. Especially for 3D printing, chamfers on the edges are very nice. We select an edge. There are now various options in the task menu and we select chamfer. Now we can manually select the edges we want to chamfer or simply check the box to select all edges and enter the chamfer length, in this case 0.5 mm. Our bolt is already looking quite good, only the 1/4 inch internal thread is missing. To do this, we select the top face of the bolt and in the task menu we choose a hole option. We find the appropriate thread and check Modeled Thread. This way, the thread isn't just displayed for the drawing, it is physically modeled and can be manufactured with a 3D printer, for example. The software has to compute quite a bit here. On slower computers, this might take a few seconds. For more complex parts, it is best to model the thread only when the entire design is finished. Otherwise, further processing can be severely delayed. Now, our threaded bolt is finished, and we should save the file. From the finished model, you can now create a manufacturing drawing, a CAM file for CNC machining, or a file for the 3D printer. To export the part, the body must be selected by double-clicking the model or selecting it in the tree view on the left. Then we can go to File, Export to select the appropriate file format and save our file for further processing. I like to use the OBJ format as it saves radii and details even more precisely than the STL format. We can now load this file into the slicer and prepare it for 3D printing. My print turned out very nicely and fits perfectly, and I hope this tutorial was helpful to you. I will look forward to your feedback and questions in the comments, so I can address your requests in the future. Thanks for watching.